Hi everybody. In this video, we're going to use the process of iteration to find the roots of an equation. And I'll show you how this works. We're given f of x here, and we're trying to solve f of x equals 0. So we're trying to solve x squared minus 5x plus 2 equals 0. And when you solve this equation, we find the roots of x. So this is where the function would pass through the x-axis. And we begin this process by breaking this up into an x term and another function of x. And then we sketch each of these. We have the line y equals x, and we sketch y equals g of x. So the first thing we need to do is to show how this can be written in this form. Well, you can see we've divided everything by the x. You can tell this from 2 divided by x. So we'll divide both sides of this equation by x. This will give us x minus 5 plus 2 over x will equal 0. 0 divided by x is still 0. And now you can see we've moved the negative 5 and the 2 over x to the right-hand side. So x will equal 5 minus 2 over x. And we can use this for our iteration formula. So we'll say the next value of x, n plus 1, will equal 5 minus 2 over the current value of x, xn. And we're told the first value of x to use, our first guess, is x equals 1. And we can visualize this graphically. If we pick this point when x equals 1, we go up to a blue curve, and we get the point 1 and y, but we need the y value. So we substitute that value of x into here. So the next iteration, x2, will be 5 minus 2 over the current iteration 1, and 5 minus 2 will give us 3. So the coordinate on the blue curve is 1, 3. Now from the blue curve, we go across to the line y equals x, and we get to this point. Now at this point, y equals x. So if y equals 3, then x also equals 3. Then we go up to the blue curve, and we have the coordinates 3 and y. So to work out the next iteration, x3, this will be 5 minus 2 over the current iteration, x2, which is 3, and this will give us 4.3 recurring. So I'll label this on a graph. And now we go across to the line y equals x. We'll go back down. So our next iteration is 4.33. And you can see, as we try more iterations, we're getting closer and closer to this intersection, which is the root of the original equation. So x4 will be 5 minus 2 over 4.3 recurring, and this will give us approximately 4.54 to 2 decimal places. So this is the general idea, but I want to show you a really quick way of doing this on a calculator. We enter g of x. So we've got 5 minus 2 over x. And we use the first iteration of x, which is when x equals 1. And we can execute that. And we get the 3, which we expected. Now we go back to the calculator, and you can replace this 1 with the answer. So it uses the answer to work out the next value. We'll press execute, and we get the 4.3 recurring. We can execute that again. We get 4.54, and we can keep executing that until we get the answer perfectly to 2 decimal places. And you can see this is 4.56. So we'll say that x is actually equal to 4.56 to 2 dp. I'll rub that one out. Let's try another example. So now we've been asked to show that this equation can be arranged into this form. So often, the most difficult thing is identifying which x to make the subject. Well, you can see we've kept the x squared. This is now a positive and a positive 1. So we've moved these two terms over to the right-hand side. So x cubed, adding x squared to both sides, will be x squared, and we'll add 1 to both sides. So we get x squared plus 1. We can cancel out this cube, or take the cube root of both sides, and we get the cube root of x squared plus 1. So our iteration formula is the next value of n will be the cube root of the current value of n squared plus 1. And we're told our first value of x is xo equals 1. So the next iteration, x1, will be the cube root. We'll substitute xo into here, and we get 1 squared plus 1. So we get the cube root of 2. For x2, I'll work this out on the calculator. So we've got the cube root of the original 1 squared plus 1. Now we go back to the calculation, and we replace the 1 with the previous answer. So x2 will be 1.3728. x3 will be 1.4253. x4 will be 1.4465. To find it to 3 decimal places, we'll keep executing it until it settles on a 3rd decimal place. And you can see this is going to be when x equals 1.466. Let's try one more question. So do you want to read through this question yourself and give it a go? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we've been given f of x equals 0. So negative x cubed plus 4x squared minus 6 will equal 0. Now we need to identify which of these x terms to make the subject. The clue is this 4 minus x term. If we need this to be a 4, then we have to factor out the x squared. So we'll have x squared multiplied by the negative x plus 4 minus 6. And I'll change its bracket to be 4 minus x. We'll move the negative 6 to the right-hand side, and we'll divide both sides by the 4 minus x. We'll take the square root of both sides, so x will equal the square root of 6 over 4 minus x. And that's what we were asked to show here. For part B, starting with x1 equals 1.5, calculate the values of x2, x3, and x4. So if x1 is 1.5, x2 will be the square root of 6 over 4 minus 1.5. We'll put this into our calculators, and we get 1.54919. We'll go back to the calculation, and we'll replace the 1.5 with the previous answer. So x3 will be 1.5647. x4, 1.5696. And then for part C, using a suitable interval, showing that the 1.572 is a root of a function of x equals 0 to 3 decimal places. So to show it's a root, we need to show a change of sign at the upper and lower bound of a 1.572. So x has a range from 1.5725, which is the upper bound, and the lower bound is 1.5715. So we work out the function of each of these values. We substitute each of them into the original function of x. Now I find it much easier to enter this value of x and to store it as a variable. So if we have 1.5715 and we enter that as a variable a, then all we need to do is negative a cubed plus 4a squared minus 6, and we get negative 0.0025. We do the same for the upper bound, 1.5725. I'll store that as variable b. And then we have negative b cubed plus 4b squared minus 6. And we get 0.002616. So we can say that the change of sign and the function is continuous within the range. Therefore, x equals 1.572 is a root. Well, thank you for watching. I hope that's given you a good idea on solving equations by iteration. If you want more practice on this, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.